My research interests are broad, from the general philosophy of science to the philosophy of physics, of climate science, of mathematics, and of the biological sciences. But here I will just present one focus of my work, namely chaos and unpredictability. Suppose you're interested in the winter air temperature in London at noon. In 1964, Edward Lorenz, one of the most outstanding meteorologists ever, came up with a simple model of variables such as the winter air temperature, namely the so-called logistic system. Here xt is the winter air temperature in London at noon at day t. And the equation tells you how to calculate the air temperature at day t plus 1 from the air temperature at day t. So for instance, from the temperature today you can calculate the temperature tomorrow and by iteration for all future days. The weather system is deterministic. Given the exact initial state, the state of the system is determined for all future times. But now look at the time series of the air temperatures generated by the system over 100 days. The behavior of the system here looks entirely random and irregular. What this shows you is that the logistic system is an example of chaos. Chaotic systems are deterministic systems which nevertheless show random and irregular behavior. Chaos has only been investigated from the 1960s onwards. It arises in many areas, from physics to biology to the social sciences. Deterministic systems can be unpredictable because we don't know the exact but only the approximate initial state. Indeed, from the beginning of chaos research until today, there has been a widespread belief that chaotic systems show a special kind of unpredictability not shown by other deterministic systems. So what is this special kind of unpredictability? This question is important because we want to know how scientists are limited in making predictions. Several answers have been proposed. However, these answers fail because the kinds of unpredictability which are claimed to be special are also shown by clearly non-chaotic systems. In my research, I was able to identify the special kind of unpredictability shown by chaotic systems. Let me explain. I will start with an example. That the winter air temperature in London at noon is between 7 and 7.5 degrees today does not help you to make any, even not probabilistic predictions about the winter air temperature in 2 weeks. This example illustrates the concept of probabilistic irrelevance. This is when knowledge of the approximate initial state does not help you to make any, even not probabilistic predictions about the future state. The special kind of unpredictability shown by chaos is the following. Whatever your approximate knowledge of the initial state, this knowledge will be probabilistically irrelevant for making predictions which are sufficiently far in the future. For example, this means whatever your knowledge of the winter air temperature in London today, this will be irrelevant for making predictions about the air temperature sufficiently far in the future. So the moral is that for chaotic systems, whatever your knowledge of the initial state, this knowledge will be completely irrelevant for future predictions. This result is important. It shows us that for certain systems in physics, biology, and the social sciences, we cannot hope to arrive at better predictions, and then policy decisions have to be based on the uncertainties presented by the unpredictability.